Assalamualaikum warahmatullahi wabarakatuh. Today, our group will present about the high voltage engineering project, and the title is Design the Conceptual Model of 132 kV High Voltage Suspension Type Overhead Line Insulator. First of all, I will introduce my group members, which are Ahmad Akmal bin Aziz and me, Muhammad Azim Akif bin Zainal. And then Muhammad Azim Nashraf bin Zulkifli, Nur Shahira binti Sahruddin, Wan Hazira binti Wan Omar. This is the outline of the presentation of our project. So I will present about the introduction. An insulator is the most important component in high voltage system, especially transmission line. It can be classified into three types, which are pin type, suspension string type, or strain type. For overhead lines above 33 kV and substation aerial conductor bus bars, suspension or tension cap, and pin or long rod insulators units are used. It must be capable of supporting the conductor under the most onerous loading condition. In addition, voltage flashover must be prevented under the worst weather and pollution situations, with leakage currents kept to negligible proportions. There are three basic dielectric materials available, such as polymetric composite, high-tempered glass, and ceramic types. Insulators are used in electrical equipment to support and spread electrical conductors without allowing currents through itself. So this project describes the different types of overhead line suspension insulators, their design characteristics, and their application. To design and construct a conceptual prototype, consideration of design and material, especially for size and creepage, have been done to make sure the testing is successful. So this is the picture of the type of insulators. That's all from me. The other slide will be presented by my friends. Thank you.
Assalamualaikum. My name is Nushaira bin Shardin. I will explain about problem statement. The discovery of electricity has led to the development of an electric power transmission system, which consists of stage of generation, transmission, and distribution system. The installation of high tension line in industrial area is one of the major problems in the operation of high tension system. Since the high voltage transmission line insulator provide insulation and mechanical support between the transmission line and the pole that are often exposed to the atmosphere. Therefore, the performance of these insulators is strongly affected by environmental condition, in which is exposed shape and the intrinsic properties of the insulation. The capability of the high voltage overhead line suspension insulator to withstand an extra high voltage, which 132 kV of alternating current voltage stress, has become a major concern in this project. This project helped to design a 2D and 3D the high voltage insulator that has capable to support under onerous loading conditions, because high voltage is the electrical energy at voltage high enough to inflict harm on living organism. This project also investigate the electrical characteristic of 132 kV insulator of ceramic material. The result of the design of suspension type of insulator by using a ceramic with a bowl and a plate shape. This project also performed test setup for appropriate high voltage testing that considering correct equipment, safety and practical procedure of an insulator. Next. The objective of this project will be conducted based on the following objective. First, designing and draw high voltage insulator proposal design using 2D or 3D drawing software. Second, constructing a prototype of accepted design. Third, able to conduct high voltage testing of the prototype by taking correct equipment safety and practical procedure as consideration. Next, for the scope of this research as follows. First, the case studies considering the design of high voltage insulators that can withstand at extra high voltage 132 kV of alternating current voltage stress. Second, 2D or 3D software will be used to design the prototype model of the insulator. Third, conduct risk assessment for high voltage AC testing and FEA analysis of the prototype. Second, produce the performance of high voltage testing method. Fourth, analyze the performance of high voltage testing method to the constructed prototype. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Marhazira binti Wan Omar and I'm going to present the concept design and methodology for this project. So firstly, for the design, we decided to use ceramic for the material to be tested in this project. And then as for the core root, we select ceramic pipe with sand compressed inside of the root. So why we choose ceramic? So the reason we choose ceramic is because it can withstand high temperature and it is waterproof. So the design specification for this project is as follows, in which this is the 2D design and this is the 3D design. So we had designed this in FEMM software. And so the type of insulator is suspension and the material sheets that we use is ceramic. And then the permittivity for the ceramic is 4.5 to 6.5 and the shades is plates and bowl. And for the material for the core root is ceramic pipe with sand inside it. For the sand, the permittivity is 5. And the material and fittings that we use is metal hooks. And for the dimension, firstly the length is 30 cm. Next, for the plates radius, it is 12.5 cm. And for the plate thickness, it is 0.5 cm. And bowl radius is 8.5 cm. For the bowl thickness, 0.5 cm. And lastly, for the gap between plates and bowl, we choose 8 cm. Next, I will proceed with methodology. So this is the flowchart that illustrates the methodology for this project. Firstly, we need to create new problem, which is electrostatic problem. And then we define the problem. For the problem type is asymmetric. And then we model the design in FEMM software. We need to set the material, boundary, and conductor accordingly to the design that we have specified before. And then we create block type, which is air, and we mesh it. After that, we will get the result of the mesh and we can analyze the result. And the process ended there. So this is the process of FEA simulation. Like I said before, we need to set the electrostatic problem. Why? We use this because we need to get electric field Emax V over M for the insulator. During modeling design, the length unit is in centimeters and the grid is set to 1.0 in Cartesian coordinates. After setting up the conductor and ground value for the insulator, materials of insulator are defined. By using existing numerical method, FEMM software managed to create mesh with existence node to be analyzed with the results. So that's all from me. Next, my friend Akmal will present the results.
Okay, Assalamualaikum warahmatullahi wabarakatuh. I am Ahmad Akmal bin Aziz. Now I will explain about our results for this project. The first result is regarding of relationship between the length of insulator and sorry about that. Okay, the first of result is about relationship between the length of insulator and 132 kilovolt across to the insulator by FA simulation. We use FAM software as our FA simulation software. And we got the prototype meshing for potential across insulator by using FA simulation. We got this type of meshing. Then we run this meshing to get the graph about voltage against length. Okay, what we can to analyze from this result is we can see the maximum voltage at nearest to conductor, which is 127.96 kilowatt. This voltage we got from the nearest distance of insulator from the conductor, which is the place that we inject the 132 kV, which is the 1.30 centimeter. And this graph will be declined to 0 as we go through the ground to the ground spot. We got the 0, which means the nearer the place towards the conductor, we will get the higher voltage, which is 127.96 kilovolt. Now I will show about our other result, which is regarding of relationship between the length of insulator and field intensity of the insulator by FA simulation. Then we got this result. Okay, from this result from this meshing prototype we run to get the graph, which is the graph of field intensity against length. As we can see from this graph, the maximum field intensity, which is 3.91431 megavolt over meter, which is the highest field intensity, and the length is 1.30 centimeter, which is the nearest length of insulator towards the conductor. We get the maximum voltage and also maximum field intensity. As we can see in this graph, the field intensity will be declined and will be minimized towards the middle, because the prototype we built is there are 3 shades, which is the highest diameter of shade. We use the plate, and also second plate, which has the highest diameter also. But between of these plates we use the balls, which is the shortest diameter. We use this design because, as you can see, the highest diameter will protect this shortest diameter from the wet condition, maybe the dust from being polluted, and insulator can be used longer. Then the last diameter shades as the highest because it is nearest to the pin and it can withstand the highest voltage there. That's from the analysis that we can get from this result. And we summarize the result to 3 column, which is we put the length of insulator nearest to conductor, which is 1.30 centimeter, and we got the result of electric field intensity and potential at nearest insulator to conductor, which is 3.91431 and 127.96. That's all about the result and the summarize for the result. Okay, that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Junata bin Zulkifli. My message number is TE170099. Today I would like to present about our conclusion and recommendation. As a conclusion, the objective of this project have been achieved by using FEA simulation. By using the FEM software, we can learn the way of creating insulator model for finite element analysis by taking material properties, boundary condition, and mesh generation into the consideration. From this project, we also know the ceramic is one of the best insulator. For this project, for the future recommendation work, we recommendation the coating the insulator using water repellent silicone type such as RGV silicone rubber coating which can reduce the leakage current and prevent arching.